Last winter was really cold in the wine farmer house. Although we heated with like electric heaters, they were impossible to regulate. I need to make progress. So heating systems on the radar, but really, what can I do? Let's have a look. Project management wise, can I start with the heating, with the dimensions? What options do I have? What amortization time for investments do I calculate? What energy source I would choose? Likely it's going to be a heat pump with energy out of the earth, which requires drilling holes. But let's see whether that's really the conclusion. Usually I would start with getting the whole concept for the whole house. I would get plans, I would get a building permission, and then I go from basically high level down to detail. And once I know everything about the house, what the insulation is going to be, how thick the roof insulation, what type of wall insulation, ground insulation, when I can do all of this, then I have the energy use requirements, and then I can go on my next phase and do like planning, ordering, etc. Now my question is, can I start in parallel? What's the minimum I need from here that I can already start figuring out what can I do already in the area of heating? The options I have for the heating, it's the electric, purely electric. There are ovens that take the cheap energy at night, heat up some stones, and then release the energy during the day. Problem is that that was designed a long time ago when the night electricity was cheaper than it is today. Now the price difference is only 10%, not what I want to continue with. Second option, and actually part of the house does have gas heating, but the gas network will be discontinued, and it's not encouraged to do any further investment into gas heating. So then the more modern choices, of course, we leave out sort of oil at the same time. So the more renewable and ecologically friendly options are the air-based heat pump, or then the earth-based heat pump. And the difference between those two is basically number 3 is cheaper but noisy, cheaper in investment, I mean. And option 4, the earth heat pump, needs the drilling, which is expensive, but then it's not noisy. Can I start with the drilling soon? I'd really like to make progress in the renovation. Do I have enough information to get started with the drilling? And does it make sense to drill at all? Because drilling, that will cost 30 to 40,000 Swiss francs. So first question, basically ruling out electric, ruling out fossil, is between the heat pumps, the air and the earth. What are the amortization times? That's where you need a few assumptions, a bit of knowledge about these systems. What I learned is that the air heat pump has an efficiency coefficient of 2.8 to 3.5. Meaning you put in 1 unit of electric energy, you get out units of heat energy. And the same for the earth heat pump. There the coefficient is around, the efficiency coefficient around 4.5. And that's because the earth is just a bit warmer during the year, and I can extract some energy out of it consistently over the year. This difference in efficiency needs to be big enough in Swiss franc terms that I can amortize the drilling of the hole. And I have to figure out what are my running costs every year for these two options, then figure out whether that leads to a good amortization of the drilling of the hole. Remembering that I'm not precise with how my home is going to be sized and insulated. So there needs to be some analysis around whether that all is sufficiently precise for my project planning. The biggest assumption that I have to make at the moment is about the energy consumption. Since this is one of my core assumptions, I really have to validate whether that's correct, whether that makes sense. But let's do the math and let's see how far we get, and then go back and check what happens if that number would be off a bit. So according to that initial estimated 35,000 kilowatts hour per year is what I need as a energy to heat the house. So now the air option would, let's use a factor of 3 here. So calculator, 35,000 kilowatts per year divided by 3. It's basically 12, roughly just under 12,000 kilowatt hours per year. That's the electricity that needs to be put in. If I do the same for the earth pump, I divide by 4.5, then I get around 7,800 kilowatt hours per year. 4,200 kilowatt hours per year. Then I need to know the electricity cost, which is 0.32 Swiss francs. That gives me a difference of 1,344 Swiss francs per year. If drilling a hole is 30,000 Swiss francs, then this gives me an amortization time of 22 years. The lifetime of such a drilled hole is around 50 to 75 years. So that should actually make sense. Let's make the assumption, okay, the thing I'm interested in, does this make sense, and how much of a hole I really need. The first 30,000 is an estimate, and the amortization seems to be reasonable, but can I really figure out the dimensions of this to already start? And do I need one hole or do I need 2 holes? How do I figure out, can I really in my project plan start with drilling a hole into the ground, or is that really not the right thing to do? Then how do we dimension this, size this? 35,000 kilowatt hours per year is what I need in total. I figured out that 7,800 kilowatt hours per year is coming out of the electricity that I put in. Earth itself needs to provide 27,200 kilowatt hours every year. So now I don't know, I need another assumption, which is how much time is the heat pump really pumping at all? And then how much do I get out of every meter of soil that this hole passes through? So let's add these additional assumptions that the heat pump will run roughly 2,000 hours every year, and there will be 30 watts per meter of heat coming out of the earth. 27,000 divided by the 2,000 hours is 13.5 kilowatt every year. Now I divide this by the 30 watts I get out of every meter. Turns out to be 0.45, which is 450 meters depth. That's the length of the rod that extracts energy from the earth. Now I know, based on local regulation, that there is maximum 300 meters allowed, which means basically I need 2 holes at 225 meters each. That's already an interesting result. I know that I can ask for permission, which is a critical lead time, putting in a building permission or request to be allowed to put in such a hole in the ground. I know that I need 2 holes, and I can maybe round it up. I can go up to 300 meters if needed. 225 meters of drilling for the 35,000 kilowatt hours per year. Is this number the two really robust? I can drill up to 300 meters. So if I have two holes, I can go to basically twice 300 meters, gives me the 600 meters in total, and I start off with the 400 meters. So before I max out on the two holes, I still got from 450 to 600, which means plus 33%. So if my initial estimate of the 35,000 kilowatt hours, the one number that I'm really unsure about, if that's wrong by more than 30%, and it needs to be more than 33% bigger, then I need three holes, and that would be not a good idea to then like plan for two holes, apply for permission to buy two holes, and then later figure out I need three. So my 35,000 kilowatt hours per year is a crucial number. I do want to have some experts that help me, but also I think 33% uplift before that's wrong is a good one. So quickly the same thing on the downside. If I only go for one hole with 300 meters versus the 450 that I'm planning for at the moment, it's actually the same in the other direction. So if I'm wrong by 33% downwards and I would only need one hole, I've got both sides, a third up or down. I'm gonna validate with other experts whether these 35,000 kilowatt hours per year are somewhat correct, and whether that margin of error can lead to a decision right now, but let's stick with this assumption. And then very briefly, what will this whole thing cost per year? So from these 35,000, we've got some out of the earth and 7,800 kilowatt hours per year that needs to be paid in electricity. Electricity price times 0.32 Swiss francs per kilowatt hour gives me a roughly 2,500 Swiss francs per year in electricity cost relating to heating. There needs to be some other electricity for all the devices, but for heating, 2,500 Swiss francs per year seems to be right order of magnitude, actually cheaper to what I'm used to and much cheaper compared to the electric heating. So the conclusions are, the assumptions are crucial, and the main assumption of the 35,000 kilowatt hours per year, I can be in the range of plus 33% or minus 33% for my calculations still to be valid. Secondly, cost reasonable. And thirdly, from a project management perspective, I have the impression that I can investigate further, get offers for drilling, get offers for heating, and run in parallel, as long as I don't change the main metrics of the house further than this. So let's go ahead, let's plan for a 225 meters of drilling for the 35,000 kilowatt hours per year. Is this number the two really robust? So I can drill up to 300 meters. So if I have two holes, I can go to basically twice 300 meters, gives me the 600 meters in total, and I start off with the 400 meters. So before I max out on the two holes, I still got from 450 to 600, which means plus 33%. Very briefly, what will this whole thing cost per year? Roughly 2,500 Swiss francs per year in electricity cost relating to heating.